Good morning, students. So today we will start our second video of chapter 3. So in the last video we have discussed about the force, okay, then moment of force, fine, and we have discussed about the units of force also, and we have done two questions. So today we will move to pressure. So we will see what actually is pressure. So in every day-to-day life, we apply pressure. What is pressure? Generally, we apply a force in a unit area. That is our pressure. Okay, if we apply some force on certain thing, that means we will say that we are applying a pressure. Okay. So whenever we apply a pressure, that pressure is our whenever we apply a force, if we apply that force, something is compressed. Okay, so if we see the definition, what is actually the pressure? It is the thrust. Okay, what is thrust now? Thrust is our compressive force, the force that is used to compress something. That force is our compressive force, and that compressive force is known as our thrust. Okay, so the thrust, or we can say compressive force acting per unit area, per unit area. That means in a unit area, if we apply some compressive force, that is known as our pressure. Okay, so if we see the formula, what is pressure? If we represent pressure by P, then it is a force acting per unit area. Per means the area will be in the denominator. Okay, so here P is our pressure and F is our force and A is our area. Okay, what is A? Area of cross section on which the force is acting. So A is our area of cross section. I think it's clear. Okay, so P equals to F by A. Using this we can calculate, we can solve the numerical values also. Okay, now we will see the SI unit of pressure. So SI unit of pressure is our so if you remember the last class, what was the SI unit of force? SI unit of force is Newton, and similarly SI unit of area will be our meter square. Okay, so if we use these two in the formula for pressure, then in numerator we have Newton and in denominator we have meter square. That means this will be Newton per meter square. So that means if we take meter square to the numerator, it will be m power minus 2. Okay, so SI unit of pressure is Newton per meter square, or we can write this as n m power minus 2. Okay, so now sometimes the question may ask that define okay okay, wait. So this Pascal, sorry, Newton meter square is also known as Pascal. Okay, here you can write one note that Newton per meter square is called Pascal. Pascal. Pascal is also the unit of pressure, and Pascal is nothing but your Newton per meter square. So in short, we write it as capital P and small a. So sometimes in question it may be asked that define 1 Pascal. Okay, so question will be asked that like this, that define 1 Pascal or 1 PA. Fine. So how we will define 1 Pascal? What is 1 Pascal? When a force of 1 Newton acts on a area of 1 meter square. Because what is Pascal? Pascal is our Newton by meter square. That means this Newton is a force. So if we apply a force of 1 Newton in 1 meter square area, then we will get 1 Pascal. So you have to write that when a force of 1 Newton, when a force of 1 Newton acts on an area of, what should be the area? It will be 1 meter square, comma, the pressure then, or we can say the pressure acting on the surface is 1 Pascal. Okay, 1 Pascal. Clear? So from this, what we can conclude? Conclusion. So what we can conclude? We can conclude the what is force? Force is equals to Newton. Pressure is equal to force per unit area. That means what we can conclude? First, we can conclude that pressure is directly proportional to force. And this, what is this force? This is our compressive force. Okay, as pressure and force are in the numerator, so that will be directly proportional. And secondly, what we can say that pressure is inversely proportional to area of cross section. Why inversely proportional? Because area is in the denominator. So that means if area is more, then pressure will be less, and if force is more, pressure will be also more. As to your pressure is directly proportional to force, that means if the magnitude of force is more, then your pressure will be also more. Clear? So if we write the meaning, let us remove this. So you can write that is more the force means compressive force, or we can say thrust. More the thrust, more the pressure. Or we can say less the force, that is thrust, less will be pressure, as it is directly proportional. So if one increases, then another one will be also increase, and one decreases, then another one will also decrease. Similarly, our second point is pressure is inversely proportional to area of cross section. Okay, so what does this mean? This means that less the cross section area, more the pressure. That is, less the area of cross section, more the pressure. Okay, and more the area of cross section, less the pressure. So like this. Clear? Okay, so there are some example numerical problems are given. So we can see some examples related to pressure. Suppose we are walking, so our foot is applying a pressure on a unit area. Then area will be the surface area of our foot. Okay, so suppose this is our foot, so we are applying a force in this area, because our shape of the foot will be like this. So we are applying a force on the ground. On which area? That area will be equals to the area of our foot. Similarly, you can see the elephants. Okay, so elephants also apply when they are walking, so they are applying a force. Okay, they are applying a pressure on the ground. Okay, so whenever the vehicle also move, then also the tires of the vehicle is applying a force. And what will be the cross section area? Because whenever they are on the ground, their shape of the tire will be like this. Okay, only the small portion is on the ground. Clear? So these are some examples in which we can see the pressure. Okay, and sometimes whenever we cut something with our knife, we apply the force on the knife. Okay, so let us see some numerical problems to how to solve the pressure. So in page number 40, not 40, for 39, in page number 39, you can see the first example. What it is written? The question is a force of 25 Newton. Question number 1. Okay, so force is our 25 Newton is given, acts on a body of unit cross section area. So area of cross section is also given, 20 centimeter square. So calculate the pressure exerted by the body in pascals. That means we need to calculate the pressure and this will be in terms of Pascal. Okay, so to convert it into Pascal, our area must be in terms of meter, then only, because what was the definition of Pascal? Pascal was Newton by meter square. So force is in meter, it is correct, but area is given in centimeter square, but we need to convert it into meter square. So first what we have to do, we have to convert the area of cross section in terms of meter. So how we to convert it? Because it is centimeter square, and we know that our 100 centimeter is equals to 1 meter, or from 1 centimeter we can say 1 by 100 meter. So we need centimeter square. So 1 centimeter is square will be 1 by 100. So we have to square 100 also. So 100 square by meter square. That means 1 by 100,000. 100,000, 10,000. 10,000 meter square. Meter square, yeah. So to convert centimeter square into meter square, we need to divide it by 10,000. So therefore, area will be 20 by 10,000 meter square. So if we solve this, these two cancel out, and 2 5s are 10, 0 0. That means 1 by 500 meter square. Now we can calculate the pressure. So we know pressure equals to force by area. So force is given 25 into area is 1 by 1 by 500. So if we convert it, so this will be 25 into 1 by 500 will get reciprocal 500 by 1. So this is 25 5 ja 125. So 125 and 0 0, and unit will be Pascal. So therefore pressure is equals to our 12,500 Pascal. So in this way we can calculate it. Okay, so all of you, so question number 2 and question number 3, you try to solve it. Okay, so you can see that we know that pressure equals to force by area. So we have one formula, this one. So from this also, so if we interchange P and A, this will be A equal to F by P. So this is again another formula. And from here also we can calculate the force. What will be force? We have to remove P. So P is getting divided. So if we change the side, it will get multiply. So force equals to area into pressure. So we have three formulas. So we can find the pressure, Fp equal to F by A. We can find area, that will be your force by pressure, and we can find force also. So force will be area into pressure. So using these three relation, we can either calculate pressure or area, or we can calculate force also. Fine. So let us solve exercise 3.1. All of you open page number 40. Okay. So fill in the blanks by choosing the correct word from the list given below. So list is our force, Newton, decreasing, reduce, increase, area of cross section, Pascal, pressure, and sinking. Sinking means to sink or डूब जाना जिसको बोलते हैं. Okay. So number 1, the ratio between the dash and the dash is called pressure. So what is the? It is given that the ratio between the dash and dash is called pressure. So what was the formula for pressure? You can see the first one, the ratio of force and area. So first dash it will be force, and in the second dash it will be the area of cross section. Fine. Similarly, question number 2, when a force of 1 dash acts on an area of cross section 1 meter square, the pressure exerted is said to be 1 dash. Obviously we have written the definition of 1 Pascal. So using that definition, we can say that when a force of 1 Newton acts on an area of cross section 1 meter square, then the pressure exerted is said to be 1 Pascal. So for question number 1, first one will be our force, second one will be our area of cross section. Similarly, for the second one, first one will be our Newton and second one will be our Pascal. And third one, the cutting edge of cutting instrument is sharpened because by dash the area of cross section, the pressure dash. So it is written as our the cutting edge of cutting instrument is sharpened. Why it is sharpened? Because dash the area of cross section, dash the dash increases. So from equation 1 only. So if we, what we can say, pressure and area. So if area increases, pressure decreases. Okay. So here in front of area, so if area decreases, then obviously the pressure will increase. So it will be because by decreasing pressure, area of cross section, the pressure increases. Okay. Similarly, 4. The broad tires of tractor, that is dash pressure on the soft ground and hence prevent it from dash in the ground. So what does it is, when tractor, because why it has your larger broad tires of the tractor, because it reduces the pressure. That's why if it is reduces the pressure, then it will less sink in the ground. But if the tire is your not broader, so then obviously that will sink in the ground. So it will reduce comma sinking. For the fifth one, with the increase in force, the magnitude of pressure, what does it do? So if we increase the, if the force is increasing, then the magnitude of pressure on a given area will be also increase. Clear? So your B part, it is true false. So you just solve B. C is also same. Is that true false? Then you try to solve the D also. With the increase in the weight of an object, the pressure, with increase in weight, obviously your pressure will increase. With the increase in the area of contact of an object, the pressure, with the increase in area of contact. So if area of contact increases, obviously that pressure will be distributed. So if pressure is distributed, then pressure will decrease, as we have discussed in case of our tractor. It has broad tires, that means surface area is increasing. So if area is increasing, obviously pressure will decrease. In question number 3 of MCQ, 1 Pascal is the pressure generated by force of 1 Newton on area of 1 meter square. So obviously your option is A is correct. And in question number 4, in order to glide on snow, one must wear spike shoes, flat rubber shoes, flat or long skies, and none of this. So you try to solve 4, okay, and 5 also. And E is same, column A and column B, you have to just match it. And last, the study questions, that is the turning effect of force with example. So turning effect, we have already discussed what is turning effect. Okay, define moment of force, we have discussed it, its unit has been also written. Define the term pressure, we have discussed it, we have written this also. State and define the SI unit of pressure. So you have to, what is the SI unit of pressure? SI unit of pressure is Newton meter or Newton per meter square or Pascal, and you have to define 1 Pascal. So 1 Pascal definition is also given. Okay, and from question number 3, you solve some questions, and if you find it difficult, then we can solve it. Okay, so in question number 4, study questions. Study questions. So in study questions, in question number 4, you can see a force of 16 Newton. So force is given 16 Newton acts on an area of 50 centimeter square. So area is given 50 centimeter square. So what is the magnitude of pressure? So we need to calculate pressure, but in terms of Pascal. So if it is in terms of Pascal, force should be in Newton. So force is in Newton and area must be in centimeter, in meter square. So we have to convert our centimeter square to meter square. So how to convert centimeter square to meter square? Dividing both sides by 10,000. So we will divide both sides by 10,000. So G0 cancel out. 5 to the 10, 0, 0. That means 1 by 200 meter square. So therefore, what is pressure? Pressure equals to force by area. So force is our 50 divided by area is 1 by 200. So if we solve, this will be 50 into 200. So 5 to the 10, 0, 0, 0. So this will be the pressure. Clear? Question number 5. A force of 200 Newton. So force is given. Force is our 200 Newton. Then acts on an area of, so area of cross section is given 0.16 meter square. Yes, you can see that area is given in meter square. So we don't need to convert the unit. So what is the pressure in Pascal? So we need to calculate pressure in terms of Pascal. So we know force pressure equals to force by area. So force is given 200 divided by area is 0.16. So you divide it. So if you divide, this will be 200 by 16. So if we cancel it, this will be, I think, 1250 Pascal. Clear? Similarly, you can do the question number 6 also. What is the magnitude of force? So we need to calculate force which produces a pressure. So pressure is given, it is our 7000 Pascal while acting on a surface area of cross section. So area of cross section is given, that is our 0.25 meter square. So you will use the same formula. So we know what is pressure? P equals to F by A. So pressure is 7000. We need to calculate force. So area is given 0.25. So 7000 into 0.25, this will be our force. Why? Because 0.25 is getting divided. So if you change the side, it will get multiplied. So if you multiply, this will be 70 into 25 equal to F. Therefore, F equal to 25 into 7. This will be our 175, 175 and 0. This will be 175, 0. And unit of force is Newton. So in this way, you solve question number 7, question number 8 and question number 9. All are very easy. Fine. So in the next video, we will discuss unit 2, that is pressure exerted by the fluids. And if you have doubt in the previous section, then you can ask me and I will solve that. Okay, thank you.